When alkali metals dissolve in ammonia, it gives a blue color solution, and that blue color solution is due to ammoniated electron, because alkali metals when dissolved in ammonia they form cations as well as anions. Cations are ammoniated cations and anions are ammoniated electrons, and due to this ammoniated electron the color of the solution becomes blue. And if we increase the concentration of metal in such solution, then their color shift to bronze, that is copper color. So that solution must be diamagnetic in nature. So namaskar, myself Kumar Sudhir, and you are watching me on my YouTube channel Science and Technology. Now it's your third video on alkali metals and alkaline earth metal, that is particularly S block elements. So now my today's topic is what happened when alkali metals like lithium, sodium, potassium, rubidium, cesium, these metals dissolve in ammonia. Then what happened? Then they form one highly conducting liquid or highly conducting solution, and that highly conducting solution, like any one metal from alkali metal, when it dissolves in ammonia, X plus Y mole of ammonia is used here, then it forms NH3 all X to the power 1 positive charge, because each metal loses their 1 electron from valence orbit, because all alkali metals have their configuration like NS1 configuration. So these metals, by a small amount of energy, a small amount of ionization potential, these metals can lose their 1 electron. When these metals comes in contact with ammonia solution, then they form ammoniated cation and also form ammoniated electron, that is ENS3 all Y to the power minus. Now this one is ammoniated electron, and due to formation of this ammoniated cation and ammoniated electron, that solution is a good conductor of electricity, means it conduct electricity, and also it will show a blue color. Why this solution show blue color? So this one is the cause. This one is ammoniated electron. So this ammoniated electron actually absorb the light from red frequency, and it just show the complementary color of red, that is blue. So actually the solution absorb the light ray from visible range, that is red color. So red वालों को ये क्या करते हैं, absorb करते हैं. तो red वालों को absorb करते हैं and उनके complementary colors show out होते हैं. That complementary color is blue here. And the nature of this solution must be paramagnetic. And when we increase the concentration of metal in that particular solution, then due to high concentration of M, the ammoniated cation concentration increases in such solution, and due to increase in the concentration of ammoniated cation in that particular solution, the color shift from blue to bronze, and also their nature shift to diamagnetic. So their nature becomes diamagnetic. The nature of solution becomes diamagnetic when we use a high concentration metal, and if we use a low concentration metal in ammonia, then their color is blue, and that blue color or bronze color is due to ammoniated electron in that particular system. Solution is one reducing nature solution, and that reducing nature is due to again here ammoniated electrons. Now these metals also react with ammonia gas and form metal amides, and also release hydrogen gas. So when this one is here ammonia solution, and when these metals react with ammonia gas, then it forms metal amide, that is NH2, and also release hydrogen gas. These metals react with mercury and form a different type of amalgam, and that reaction with metal with mercury and formation of amalgam is a kind of exothermic reaction, because during this reaction a large amount of heat energy is released. So when this M comes in contact with mercury, so it forms NHZ, that is one amalgam. And that process or that formation of amalgam, it must be a type of exothermic reaction. So here a large amount of heat energy is produced during this kind of change. Metal halides and other salts of alkali metals are ionic in nature except one, that is lithium. So due to a very small size of lithium, it have a high polarizing capacity. So lithium can polarize one negative ion or anion. So due to this polarizing, the nature of the salt becomes covalent. Because we know that lithium is extremely small in size and it is with positive charge. So due to one small size and high positive intensity or high positive density in lithium, it can polarize one normal negative ion like chlorine, like bromine, like iodine. So these ions, which are negatively charged ions, are slightly polarized when it comes in contact with lithium. So due to this polarization, so it's polarized just. So it's this polarization is due to the small size of lithium, and the lithium have positive value, and due to the smaller size, it can polarize easily. Now, which one is more polarized? So in case of LiF, LiCl, LiBr, Li. So in case of Li, that is lithium iodide, iodine is more polarized due to their larger size, whereas fluorine is less polarized due to their smaller size. So the nature of LiF is ionic, but this ionic behavior of the compound decreases down the group, whereas covalent nature increases down the group. And this nature is due to the small size of lithium. So that lithium has one analogous behavior or analogous trend comparison to the other elements belonging to this group. So all these elements of this group like sodium, potassium, rubidium, cesium will form ionic compound with all non-metallic groups or any negative groups like carbonate, like sulfate, like halides. So in case of जो bonding होता है वो bonding ionic होता है, but in case of lithium it is little bit shift to covalent nature, and this covalent nature is due to the smaller size of lithium and due to high positive intensity. So due to that behavior, it can polarize one anion. Polarization, it means just their electron cloud shifted towards the lithium. In case of lithium chloride, the electron cloud do not shifted towards lithium, because fluorine itself one high electronegative element, so it have a tendency to attract electron from outer sources. So fluorine have itself one character to attract electrons. So the bonding between Li and F is ionic, but the trend decreases, the ionic trend decreases here due to the larger size of an ion, and that larger size can easily polarize towards lithium. So polarization, that one is the actual size of atom, and the red dotted point is their polarized ion. So यहाँ पे क्या हो रहा है कि लिथियम के कारण वो जो इलेक्ट्रॉन क्लाउड है उनका शिफ्टिंग हो जाता है लिथियम के टुवर्ड्स, and due to this shifting of electron cloud towards lithium, the nature of the complexes becomes covalent. So Li is most covalent in nature, whereas LiF is ionic in nature. So the salts and their nature are changed from ionic to covalent when it goes from top to bottom in alkali metal group particularly. Now there are several compounds of alkali metals are used in our day-to-day life, like sodium hydroxide and potassium hydroxide are used in soap manufacturing, also in paper manufacturing. Other metallic hydroxides are also used as a medicinal purpose. So there are various use of these metals, not only these metals but also their salts and also their different complexes are used for different purposes. तो आपको लगभग इन सारे मेटल के अलग-अलग यूज को आपको थोड़ा बहुत स्टडी कर लेना है यहाँ पे। साथ ही साथ इन मेटल्स के आप अगर डिफरेंट कॉम्प्लेक्सेस की बात करते हैं तो यहाँ पर बेसिकली आप सोडियम के कार्बोनेट, सोडियम के बाइकार्बोनेट, potassium carbonate and their bicarbonate, their sulfate, So how they are prepared and how they are used, so इनके बारे में भी यहाँ पे आपको थोड़ा बहुत इनको स्टडी करना है कि आप उनको प्रिपेयर्ड आप कैसे करते हो, साथ ही साथ प्रिपरेशन के साथ उनका यूज आप किस किस लेवल पे आप करते हो। क्योंकि एस ब्लॉक में बेसिकली हम लोगों को जो अल्कली मेटल्स मैंने लिया हुआ है, तो यहाँ पे मैंने सिर्फ लिथियम, सोडियम, पोटेशियम, रुबिडियम और सीजियम पे मैं बात कर रहा हूँ। अगला वीडियो जो मैं लेकर के आऊंगा वो मैं अल्कलाइन अर्थ मेटल्स के ऊपर लेकर के आऊंगा, जो कि BeMe वाला Ca और ये सभी के जो फैमिलीज के जो मेंबर है एटम्स की ग्रुप नंबर 2, देयर कॉन्फिगरेशन इज NH2 एंड वी विल डिस्कस अबाउट इट नेक्स्ट वीडियो। सो अभी तक का जो हमारा है वो सिर्फ अल्कली मेटल के मैंने बारे में, फिजिकल ट्रेंड के बारे में मैंने बताया है, देयर ऑक्साइड फॉर्मेशन के बारे में मैंने बताया हुआ है दोनों वीडियोस में। और इस वीडियो में हम लोगों ने अमोनिया के साथ इनका रिएक्शन, साथ ही साथ मरकरी के साथ ये किस तरह के कॉम्प्लेक्सेस फॉर्म करते हैं, वैसे ही कुछ एक कॉम्प्लेक्सेस उनका फॉर्मेशन कैसे होगा, साथ ही साथ उनका क्या क्या यूज आप कर सकते हो, क्योंकि इन मेटल से कई डिफरेंट कॉम्प्लेक्स का फॉर्मेशन होता है, जैसा कि हमने कहा कार्बोनेट, बाइकार्बोनेट, तो दीज आर एसेंशियल कंपाउंड्स फॉर दिस पर्टिकुलर ग्रुप। सो थैंक्स फॉर वाचिंग मी ऑन दिस माय YouTube channel. If you are happy to see me on this YouTube platform, then please comment me. I will again form one new video. This one is the very short video, and this one is last video for alkali metals and particular in S block. In group number 1, for group number 1, we will form second video for group number 2 elements, and in that particular we will compare the group number 1 element also with group number 2 element. Okay. Like, share, subscribe. Thanks for watching.